What's up, everyone? Welcome back to Web3 SQL Weekly number 7, where I break down queries into bite-sized bits. This week, we're going to be looking at cohort retention, specifically here looking at NFT marketplaces. So we can compare like what are, for every single month's cohorts, what are their like 5-month retentions, their 10-month retentions, their 1-month retentions, basically measuring for each group of users that comes to the platform, are they becoming more sticky or less sticky over time? There's going to be some related concepts from week number 4, where we did new versus old protocol users. I'm going to talk about why we're taking a different approach here, and let's get into it. So, our question here comes from Ryan. He was specifically asking about Sandbox, but I started off tweeting a week or two ago about Opensea, looking at specifically their seaport address, right? This is a new version of their marketplace they deployed in, I think, July or June of 2022. And you can see here that the retention was like 25% around like month 5, and it's kind of been decreasing with every new cohort. But one of the issues with this is that Opensea, like many other protocols out there, have deployed many versions of their contract, right? So only looking at Seaport doesn't really give us the full picture, especially since this month 1 retention, a lot of these are probably already like sticky users from 2021 or 2020 who have stuck around for a long time, right? So to be most accurate, we need to basically accumulate all of Opensea's contract versions and addresses. So how would you go about doing that? The hardest way about doing it is you look up their documentation or GitHub repos and hope that they have everything in one place. Sometimes it works for great protocols like OpenSea and Uniswap. Other times you're basically going to be just tearing your hair out trying to figure out like, okay, which contracts do I actually look at? Another option is to find a deployer of one of the contracts and then find all of the contracts they've deployed. For OpenSea Seaport, I can see that there's an OpenSea deployer here, right? So if I copy this address and then I go into raw blockchain data and I go to Ethereum and I go to creation traces, every time a contract is deployed, it shows a creation trace, right? So there's literally a row that says code deployed at address by whom, right? So I can say creation traces, where this address is the address that was deployed, like the contract, and the from address here is who deployed it. So I'm going to say where from equals the OpenSea deployer. Because this is Dune SQL, I need to put keywords like from in quotes. And I can see here there's 9 rows. So I could just take these 9 addresses and say, okay, these are probably the 9 addresses I want. Our other option is there's also a decoded table for, I could also check, we have something from decoded tables called Ethereum contracts, or this applies to every chain, where you can see essentially the ABI, the address, and more importantly, it's probably hard to find here, but there's a name and namespace of the deployer. So I can say select all from Ethereum contracts where namespace equals OpenSea. So in this case, we could actually see there's 24 rows here. A bunch of these are conduits, it looks like, but they're all deployed under the OpenSea name. This can be confusing, right? Because OpenSea might have, and they do have, like a conduit factory where anyone can call it and create a conduit, which is kind of like a marketplace that OpenSea technically doesn't own, but the contract was created by OpenSea, so it'll still list as the namespace under OpenSea. But this is a good way of getting started on being like, okay, let me check what contracts I might be missing, right? But even if you do this, there's one problem. OpenSea, like many NFT marketplaces, the first action of like if I'm putting a bid or an offer on an NFT is just a signed message, right? You're just signing a signature saying, hey, I'm approving some sort of order. But that signature doesn't go on chain until the other side is filled, right? So if I look at any purchase or sell on Opensea, only the person who filled the order, their address is going to be tied to that transaction. But the person who signed it, because it's an off-chain action, their wallet address isn't captured, right? So we can't do what we did before with like week 4, where we just said, okay, look at traces where the contract was called, and we just take the from, and that's all the wallet interactors. It's actually not technically correct. So we need to have both the buyer and the seller side. But we're in luck. We have the NFT trades table, which if I preview in here, you'll see it has the project. So it has every single OpenSea marketplace decoded into here. And it has all of their swaps, meaning for every single marketplace on like multiple chains, but we're only caring about Ethereum, I can see the buyer and seller of each trade, no matter who submitted the offer or bid and who filled it. And I don't have to go looking for contract addresses of, do I have all of their marketplaces or not? Right. So we're going to just use NFT trades for our query. Let's get into it. So for this week, we're actually trying something new. I've split the video into 2 parts, the query walkthroughs, and the second part. You can click here to go watch it, and I'll see you there.